All right, welcome everyone. Good to have you. Welcome back. Today we're going to be talking about integrating inverse trig functions. How riveting. But before we do, let's start with a joke. Why should you always knock on the fridge before opening it? In case the salad's dressing. Okay. So let's take a look. Today we're going to be integrating inverse trig functions. Now, I am going to zoom through a lot of these formulas here. But the part that I kind of want to get to is I'll let you guys pause and kind of copy these down. Now, I want to start with these ones here because these are the ones that are given in your reference sheet, just the ones in black. Okay, so if you have the integration of some sort of derivative over an a squared minus the square of an original, then it's going to look like the sine inverse of f of x on a plus c. Okay, so that looks a little bit familiar. And if we lose the square root on the bottom, then it becomes a plus, a sum. Then it's going to become our, the integration is going to become our inverse tan with a constant of 1 on a taken out, a being that number in front of there. Now, all this is going to look confusing. I'm going to show you a whole bunch of different formulas here. So, and where it kind of derives from. And so hopefully we take you on that journey. So for this one here, we know that the derivative of sine inverse x becomes 1 on 1 minus x squared. So it makes sense that when we integrate this, we'll end up back at sine. And remember, sine and cos were very, very similar, the only difference being a negative. So we could also write this as the integration would be negative cos inverse of x plus c. Okay, and same thing, we know that the derivative of tan was 1 on 1 plus x squared. So in this case here, if we integrate 1 on 1 plus x squared, we're going to get tan inverse x plus c. Okay, don't forget your plus c's when we're integrating, especially when we're dealing with indefinite integrals. Okay, now, if you look on the right-hand side here, the only difference is now it's no longer 1 minus, it's now some sort of squared number minus. Okay, so we're going to start working with this. And the only thing that affects is it's going to start to affect your function, or it's going to start to affect the x. So if it's a squared, you're going to divide it through by a in your integration. Okay. Same thing for tan. You're going to divide through by whatever the a is. And you're also going to multiply it by 1 over a, or the reciprocal of a. Okay. Follow with me here. Now, this one here is probably going to be your most useful one. So if you do have this, it's going to be very, very helpful. So you're going to have, it's still going to be 1 over, it's going to be your a squared minus b squared x squared. What's going to happen is you're going to take 1 on b, so whatever your coefficient of the x squared is, that's what you take out the front, or the square root of it. And then you're going to have all of these. Now, I'll leave these all up for you. And also at this point here, you should also recognize that this would become the same thing. Sine and cosine is the same thing, the only difference being the negative. So it would be negative 1 on b cos inverse of bx on a plus c. Okay, now I'm going to try my best to stick with these formulas here because these are the ones that you're given in your HSC, and I'll show you how to use them. Let's start with this one here. So now we've got find 1 on the square root of 25, take away 9x squared dx. Now, I'm just going to write down the formula from before. We know that the integration of 1 over the square root of a squared minus fx squared. Oh, sorry, it should be f dash x is up here as well. F dash x dx should equal to 1 on b. Oh, sorry, 1 on, oh no, that's it. It just becomes sine inverse of fx plus c. Okay, just double checking all over a, whoops. Okay, that there will be our formula. Now, let's see how we use that here. Now, the first couple of things we need to look out for is that's an a squared. I'm going to try to use different colors here. So I know that a squared and 25 must be the same. So from there, I can kind of see that a should equal to 5. right? And I can see that that's my fx, or my fx squared should equal to 9x squared. So that means in this case, my fx should just be 3x, right? Because 3x times 3x will give me 9x squared. Okay, now let's also note, if that's my fx, I'm going to do this one in a different color now. Once I know what my fx is, well, I can see that my f dash x should now become 3. Okay, so technically, what I'm going to do here is, I can see now that the integration would be, it should be 3 on the square root of 25, take away 9x squared dx. That's what I'd want it to be, because I want my f dash x on 3. But what I'm going to do now is, this is the part that confused us before. I'm going to give a little bit of room here. What I'm going to do is I'm going to take out a factor of a third, right? So that way, when we cancel these out, it will end up with 1 on top. But I'm just doing this because now I know that that's the form of my derivative. So in other words, I know now that this part here is just going to integrate to sine inverse of fx on a. So it's going to be sine inverse of my function, which in this case is 3x. My a is going to be 5, and that's it, plus c. Okay, and that should be that. Now I'm going to leave that there. That should be enough. I know there's some other questions here. We can go through those another time. Okay, anyways, I'll catch you guys later, and I'll see you soon. Bye-bye.